Sleep paralysis is a state in which the mind emerges into wakefulness while the body remains locked in the stillness of sleep. It is a moment when consciousness returns, but movement does not. The eyes may open, the room becomes visible, sounds filter through, and yet the limbs refuse to respond. The body lies frozen, unresponsive to the urgent commands sent by the waking mind. This experience, though startling, is not a malfunction, but rather a glimpse into the intricate mechanics of sleep itself. A moment when the usual seamless transition between states becomes momentarily visible. During sleep, the brain cycles through distinct phases, each with its own purpose and character. Among these phases, rapid eye movement sleep, known as REM, stand apart. It is the stage in which dreams unfold with vivid intensity, where narratives play out in rich detail, where emotions surge and landscapes shift without the constraints of physical reality. The brain during REM sleep is extraordinarily active, nearly as active as it is during waking life. Neurons fire rapidly, memories are processed, emotional experiences are integrated, and the mind constructs elaborate scenarios that feel entirely real within the context of a dream. But while the brain engages in this intense activity, the body must remain still. This stillness is not accidental. It is a deliberate and essential feature of REM sleep, a protective mechanism that prevents the body from acting out the movements that occur within dreams. Without this paralysis, the sleeping person might thrash, run, fight, or perform any number of actions that the dream mind believes it is experiencing. The consequence could be injury, both to the dreamer and to anyone nearby. To prevent this, the brain initiates a process known as REM atonia, a temporary paralysis that affects nearly all voluntary muscles except those that control the eyes and the diaphragm. The signal originates deep within the brainstem, in regions that regulate the transition between waking and sleeping states. Specialized neurons release neurotransmitters that inhibit motor activity, effectively disconnecting the brain's motor command from the muscles that would normally execute them. The body becomes still, safe, and unresponsive, even as the mind races through the landscape of dreams. This system functions smoothly in most instances. The person dreams, the body remains motionless, and upon waking, movement returns so quickly and automatically that the sleeper never notices the transition. But occasionally, the process does not unfold in perfect synchrony. Sometimes the mind wakes first, awareness returning before the brainstem has released its hold on the muscles. In these moments, consciousness emerges into a body that is still locked in the paralysis of REM sleep. The person is awake, aware of their surroundings, capable of thought and perception, but unable to move. This is sleep paralysis. The experience of being awake yet unable to move creates an immediate and profound sense of alarm. The mind attempts to lift an arm, to turn the head, to sit up, but nothing happens. The body does not respond. Effort increases, but the limbs remain heavy, unresponsive, as though weighed down by an invisible force. Panic begins to rise. The heart rate increases, breathing becomes shallow and rapid, and the mind searches urgently for an explanation. Why can't the body move? What is happening? The inability to understand the situation in the moment intensifies the fear, and fear, in turn, shapes what happens next. The brain does not exist in isolation. It is constantly interpreting sensory input, constructing a coherent narrative of reality based on the information it receives. When sensory input is ambiguous or incomplete, the brain fills in the gaps. It generates explanations, images, and sensations that align with its expectations and emotional state. During sleep paralysis, the brain is caught in a liminal space between sleep and waking. Some regions have fully transitioned to wakefulness, while others remain in the dream state. This partial activation creates a unique environment in which the boundaries between perception and imagination blur. The visual cortex, responsible for processing sight, may still be influenced by the dream-generating mechanisms of REM sleep. The auditory cortex, which processes sound, may interpret the silence of the room in unusual ways. The somatosensory cortex, which registers touch and bodily sensations, may generate feelings that have no external source. And overseeing all of this is the amygdala, a small, almond-shaped structure deep within the brain that plays a central role in processing fear and threat detection. During REM sleep, the amygdala is highly active, contributing to the emotional intensity of dreams. When sleep paralysis occurs, the amygdala remains in this heightened state, primed to interpret ambiguous stimuli as dangerous. The combination of immobility, partial dream state activation, and heightened fear response creates the conditions for hallucinations. These are not hallucinations in the sense of random, meaningless distortions. They are the brain's attempt to make sense of a confusing and frightening situation. The mind, unable to move and searching for a reason, generates explanations that align with the feeling of threat. If the body cannot move, something must be holding it down. If fear is present, something dangerous must be nearby. The brain, operating on this logic, begins to construct a narrative, and in doing so, it creates entities, presences, and sensations that feel utterly real. The most commonly reported hallucination during sleep paralysis is the sense of a presence in the room. This is not merely a vague feeling, but a vivid, undeniable certainty that someone or something is there, watching, lurking just out of sight. The person cannot see this presence clearly, but they know it is there. The knowledge is visceral, immediate, and absolute. This sensation arises from the brain's threat detection systems, which are operating in overdrive. The amygdala, flooded with signals of danger, interprets the ambiguous sensory environment as containing a hidden threat. The brain constructs the presence as a way of explaining the overwhelming feeling of being in danger. Often, this presence is perceived as malevolent. It is not neutral or benign. It feels hostile, predatory, intent on harm. This perception is shaped by the emotional tone of the experience. Fear generates the expectation of danger, and the brain, seeking to match perception with expectation, creates an entity that embodies that danger. In many cases, the presence is seen as a shadowy figure, a dark silhouette standing at the edge of the bed, in the doorway, or in the corner of the room. The figure is often indistinct, lacking clear features, but its outline is unmistakable. It is humanoid, but not quite human. It is still, but seems poised to move. The shadow figure is a product of the visual cortex interpreting low light and ambiguous shapes through the lens of fear. Shadows that would normally be ignored become meaningful. The brain's pattern recognition systems, which are extraordinarily sensitive to human forms, detect a figure where none exists. Accompanying the visual hallucination is often an auditory component. The person may hear footsteps, whispers, breathing, or indistinct voices. These sounds are generated internally, the result of the auditory cortex interpreting the silence of the room or the subtle background noises that are always present but normally filtered out. During sleep paralysis, the brain's auditory processing is influenced by the same mechanisms that create dream sounds. The result is that ordinary noises are transformed into something eerie and meaningful, or sounds are created entirely by the brain itself, as vivid and convincing as any real sound. Another common hallucination is the sensation of pressure on the chest. Many people describe feeling as though something heavy is sitting on them, pressing down, making it difficult to breathe. This sensation has a physiological basis. During REM sleep, breathing becomes irregular and shallow as the muscles involved in respiration are partially inhibited. When a person wakes into sleep paralysis, they become consciously aware of this altered breathing pattern. The breath feels restricted, labored, as though something is preventing the lungs from expanding fully. The brain, searching for an explanation for this physical sensation, attributes it to an external force. The presence that the mind has already constructed is now given a physical role. It is not merely in the room. It is on the chest, pressing down, threatening suffocation. The sensation is real, but the explanation is a construct. In some instances, the hallucinations extend to tactile sensations that go beyond the feeling of pressure. People report being touched, grabbed, dragged, or even feeling as though they're being pulled out of their bodies. These sensations are generated by the somatosensory cortex, which is receiving conflicting signals. The body is paralyzed, but the brain is sending signals to move. The mismatch between intention and execution creates phantom sensations, feelings of movement or touch that have no external source. The brain interprets these sensations as being caused by an external agent, reinforcing the narrative of an intruder or malevolent presence. The fear that accompanies sleep paralysis is not a byproduct of the experience, but a central driver of it. The initial panic upon realizing that the body will not move activates the amygdala and triggers the release of stress hormones, such as adrenaline and cortisol. These hormones heighten alertness, increase heart rate, and intensify emotional responses. The brain is now in a state of high arousal, primed to detect threats. This heightened state makes the hallucinations more vivid, more convincing, and more terrifying. The more frightened the person becomes, the more intense the hallucinations grow. It is a feedback loop in which fear generates hallucinations, and hallucinations generate more fear. The evolutionary purpose of this response becomes clearer when considered in the context of survival. The brain's primary function is to keep the organism alive, and to do so, it must be able to detect and respond to threats quickly. Ambiguity is dangerous. Hesitation can be fatal. In an uncertain situation, it is safer to assume danger and be wrong than to assume safety and be wrong. This principle, known as threat over perception, is deeply embedded in the brain's threat detection systems. During sleep paralysis, the brain is confronted with an ambiguous and confusing situation. It cannot move, it does not understand why, and it is in a vulnerable state. The safest interpretation, from the brain's perspective, is that a threat is present. The hallucinations that follow are the brain's way of making that threat tangible, of giving form to the danger, so that, in theory, it can be responded to. Of course, the body cannot respond, but the brain does not yet realize this. It is operating on ancient programming, designed for a world in which threats were physical and immediate. Across cultures and throughout history, people have experienced sleep paralysis, and despite differences in language, geography, and belief systems, the descriptions are remarkably similar. The presence in the room, the pressure on the chest, the shadowy figure, the feeling of malevolence. These elements appear again and again. In medieval Europe, the experience was attributed to demons or witches sitting on the sleeper's chest. In Newfoundland, it was the old hag. In Japanese culture, it was known as kanashibari, a binding spell. In parts of Africa, it was blamed on spiritual attacks. The consistency of these reports points not to a universal supernatural entity, but to a universal human brain architecture. The same neural mechanisms produce the same types of hallucinations, and across cultures, people have created narratives to explain them that fit within their cultural and spiritual frameworks. The entities perceived during sleep paralysis often share certain characteristics. They are humanoid but distorted, familiar yet alien. They are silent or emit strange sounds. They are still yet seem capable of sudden movement. They are felt more than seen, sensed more than observed. These characteristics reflect the way the brain constructs threat in conditions of ambiguity. The figure is humanoid because the brain is wired to detect human forms. Throughout evolution, other humans have been both sources of aid and sources of danger. The figure is distorted because the visual information is incomplete and the brain is filling in details based on expectation rather than perception. The figure is malevolent because the emotional state is one of fear, and fear colors perception. Time during sleep paralysis is experienced in a distorted manner. Seconds can feel like minutes. Minutes can feel like hours. The person trapped in paralysis may believe the experience has lasted much longer than it actually has. This distortion occurs because the brain's sense of time is not an objective measurement, but a subjective construction based on the density of experience. When a great deal is happening, when fear is high, when attention is intensely focused, when the mind is flooded with sensory and emotional input, time seems to stretch. Each moment is packed with content, and the brain interprets this density as duration. Conversely, in moments of calm or routine, when little is happening, time seems to pass quickly. During sleep paralysis, the intensity of the experience creates the perception of extended time, even though the episode may last only a few seconds or a minute or two. Breathing during sleep paralysis feels profoundly difficult. The person may feel as though they cannot draw a full breath, as though the chest is constrained, as though suffocation is imminent. This sensation is distressing and amplifies fear. The cause is twofold. First, during REM sleep, the muscles of the chest and diaphragm are partially inhibited. Breathing becomes shallow and automatic, controlled by the brainstem rather than by conscious effort. When the person wakes into sleep paralysis, they become aware of this shallow breathing and attempt to take deeper breaths, but the voluntary control is limited. The effort to breathe deeply meets resistance, not because something is obstructing the airway, but because the neuromuscular inhibition of REM sleep is still in effect. Second, the anxiety and panic of the experience cause hyperventilation and a sensation of air hunger, further distorting the perception of breathing. The person feels they are not getting enough air, even though physiologically they are. The fear of suffocation becomes a focal point, intensifying the distress. The role of expectation in shaping the sleep paralysis experience cannot be overstated. What a person expects to happen influences what they perceive. Someone who has heard stories of demonic encounters may perceive the presence as a demon. Someone who has read about alien abductions may interpret the paralysis and hallucinations as an abduction experience. Someone who understands the neuroscience may recognize the experience for what it is and, though still frightened, may find the fear more manageable. Expectation primes the brain's interpretive systems, guiding the narrative it constructs. This is why cultural context shapes the specific details of the hallucinations, even though the underlying mechanisms are universal. The brain uses the available templates, stories, images, beliefs to make sense of the sensory chaos. Sleep paralysis occurs more frequently under certain conditions. Stress and anxiety are significant triggers. When the mind is burdened with worry, sleep becomes fragmented. The transitions between sleep stages become less smooth, and the likelihood of waking during REM sleep increases. Exhaustion also plays a role. When the body is deprived of sleep, it attempts to compensate by entering REM sleep more quickly and spending more time in it. This increases the number of REM periods and, consequently, the chances of waking during one. Sleep position matters as well. Episodes of sleep paralysis are more commonly reported by those sleeping on their backs. This position may interfere with breathing slightly, causing subtle discomfort that is more likely to wake the person during REM sleep. Irregular sleep schedules, shift work, and sleep disorders such as narcolepsy also increase the frequency of episodes. The brain is an organ that seeks patterns and meaning. It is uncomfortable with randomness and ambiguity. When faced with an experience it cannot immediately explain, it generates explanations, drawing on memory, emotion, and cultural knowledge. During sleep paralysis, the brain is confronted with a situation that feels inherently wrong. The body should respond to commands, but does not. The room should feel safe, but does not. The mind constructs a narrative to resolve this dissonance. The narrative usually involves an external agent because attributing the paralysis to an outside force is simpler and more immediate than understanding the complex neurological processes at play. The external agent becomes the villain of the story, the reason for the helplessness. This narrative provides a framework, however terrifying, for understanding the experience. Memory plays a crucial role in how sleep paralysis is experienced and remembered. The emotional intensity of the experience ensures that it is encoded deeply. The amygdala's involvement in both the experience and the formation of emotional memories means that episodes of sleep paralysis are remembered vividly, often more vividly than ordinary dreams. The details may become exaggerated in memory over time, shaped by retelling and reflection. The fear felt during the experience becomes part of the memory itself. So recalling the event brings back not just the facts but the emotion. This is why sleep paralysis can leave a lasting impression, why it can feel more significant than a nightmare, why people often remember their first episode for years. The experience feels intensely personal. It happens in the intimate space of one's own bed, in the vulnerability of sleep, in the privacy of darkness. The presence, if one is perceived, feels directed at the individual, aware of them, focused on them. This personal quality intensifies the emotional impact. It is not a generalized fear, but a targeted one. The brain, in constructing the experience, centers it on the self, because the self is the frame of reference. All perception is inherently subjective, filtered through the individual's consciousness, and during sleep paralysis, this subjectivity is heightened. The experience is not happening to someone else. It is happening here, now, to me. Logic and rational thought are diminished during sleep paralysis, not entirely absent, but significantly weakened. The prefrontal cortex, the region of the brain responsible for executive functions such as reasoning, planning, and impulse control, is less active during REM sleep. Although the person is awake, parts of the brain remain in a sleep state. The result is that the ability to think critically, to assess the situation logically, to recognize that this is a known phenomenon with a biological explanation, is compromised. The person may know intellectually, in the abstract, that sleep paralysis is harmless, but in the moment, that knowledge is inaccessible. The emotional and perceptual systems dominate, and logic takes a back seat. This is why even those who have experienced sleep paralysis multiple times and understand what it is can still feel intense fear during an episode. Knowledge helps, but it does not fully override the primal response. There is a distinction between the hallucinations of sleep paralysis and those of dreams. Dreams occur within the context of sleep, and the dreamer, for the most part, accepts the dream reality without question. The bizarre and impossible are taken as normal. The dreamer is immersed in the narrative, often unaware that they are dreaming. Sleep paralysis, by contrast, occurs in a state of wakefulness. The person is aware of their actual environment, aware that they are in their bed, in their room. The hallucinations are overlaid on this real environment, creating a disturbing hybrid of reality and illusion. The room is familiar, but within it is something that should not be there. This blending of the real and the hallucinatory is what makes sleep paralysis feel so uncanny, so deeply unsettling. It is not entirely dream, not entirely waking, but something in between. Some people experience sleep paralysis in the context of lucid dreaming or find that the awareness present during sleep paralysis resembles the awareness of a lucid dream. In both states, there's a level of consciousness that is unusual for sleep. In lucid dreaming, the dreamer becomes aware that they are dreaming and may gain some control over the dream content. In sleep paralysis, the person is aware that they are awake but cannot control their body. There is an overlap in the sense of meta-awareness, the ability to observe one's own mental state. However, lucid dreaming is typically pleasant or neutral, while sleep paralysis is almost always distressing. The overlap lies in the state of consciousness, not in the emotional tone. The vividness of sleep paralysis hallucinations often exceeds that of dreams. In a dream, details can be hazy, events can shift without clear transitions, and upon waking, much of the dream may be forgotten. Sleep paralysis hallucinations, by contrast, are sharp, detailed, and persistent. They are experienced with the full sensory richness of waking perception. The shadowy figure is seen as clearly as any real object. The sound of footsteps is as distinct as if someone were truly walking across the floor. The pressure on the chest is as tangible as physical weight. This heightened vividness is due to the fact that the sensory cortex is awake and processing information in the same way it does during normal waking life. But the content is being generated internally rather than coming from external stimuli. The brain does not distinguish between internally generated sensations and externally caused ones when the conditions are right. To the experiencing person, the hallucination is indistinguishable from reality. The transition out of sleep paralysis is as significant as the onset. Eventually, the brainstem completes the process of transitioning from REM sleep to full wakefulness, and the inhibitory signals that have kept the muscles paralyzed are withdrawn. Movement returns, sometimes gradually, sometimes all at once. The person may first be able to move a finger or a toe, then a hand, then the arm, until full control is restored. In other cases, the entire body seems to unlock simultaneously. The moment of regaining movement is often accompanied by a profound sense of relief, a release of tension, a flood of gratitude for the ability to move again. The heart rate begins to slow, breathing deepens and becomes more regular, and the immediate terror subsides. Once movement returns, the person often feels the need to sit up, turn on a light, reorient themselves in the room, and reassure themselves that they are safe. The room is checked for the presence that was felt so strongly moments before. Of course, there is nothing there. The shadows are just shadows. The sounds are just the ordinary background noise of the environment. The sense of presence dissipates as the brain fully transitions to wakefulness and the amygdala's activity decreases. The threat detection systems stand down, the prefrontal cortex resumes its executive functions, and rational thought returns. The experience, though still fresh in memory, begins to be understood in context. The person may feel shaken, confused, or even embarrassed. The intensity of the fear felt during the paralysis can seem disproportionate once it is over, but in the moment, it was entirely real. Some people experience sleep paralysis only once in their lives. It is a singular, strange event that is remembered but not repeated. Others experience it frequently, sometimes multiple times a week or even multiple times in a single night. The reasons for this variability are not entirely understood. Genetics may play a role. Some people may have a predisposition to more frequent episodes. Sleep disorders, particularly narcolepsy, are associated with higher rates of sleep paralysis. Chronic stress, anxiety disorders, and post-traumatic stress disorder can increase frequency. Sleep deprivation, irregular schedules, and substance use can also contribute. For those who experience it repeatedly, the fear may lessen over time as familiarity breeds a sense of predictability, but the experience remains unpleasant. Knowing what is happening does not make the body's refusal to move any less frustrating or the hallucinations any less vivid. The fact that sleep paralysis occurs most often at night, in darkness, is not coincidental. Darkness amplifies the brain's reliance on internal models of reality rather than external sensory input. In the absence of clear visual information, the brain fills in more, guesses more, and is more likely to generate images that align with its emotional state. The silence of night also plays a role. Without the ambient noise of daily life, subtle sounds become more noticeable, more ambiguous, and more susceptible to misinterpretation. The isolation of night, the stillness, the vulnerability of being alone in the dark, all contribute to the atmosphere in which sleep paralysis feels more intense. The environment itself becomes part of the experience, shaping how the hallucinations are perceived. The lasting impression left by sleep paralysis is not merely a function of the fear experienced, but of the profound strangeness of the event. It is an encounter with the hidden workings of the mind, a moment when the boundaries between sleep and waking, between imagination and perception, become visible. It is a reminder that consciousness is not a simple on-off state, but a complex, layered process that can be disrupted, revealing the machinery beneath. For many, the experience prompts questions about the nature of reality, perception, and the reliability of the senses. If the mind can generate such convincing hallucinations, What else might it be constructing without one's awareness? The brain learns from sleep paralysis. After an episode, particularly a frightening one, the brain forms associations. The bedroom, the act of falling asleep, the feeling of drowsiness, all can become linked with the fear of another episode. This anticipatory anxiety can, paradoxically, increase the likelihood of recurrence. Anxiety disrupts sleep, and disrupted sleep increases the chances of waking during REM. The person may become hypervigilant as they fall asleep, monitoring their body for signs of paralysis, and this monitoring can interfere with a natural transition into sleep. The fear of sleep paralysis can become a self-fulfilling prophecy. Breaking this cycle requires understanding, exposure, and, in some cases, techniques to manage anxiety and improve sleep quality. There is something ancient about the experience of sleep paralysis, something that feels primal and deeply embedded in human existence. The sensation of being watched, of being threatened, of being helpless in the face of an unseen danger. These are fears that reach back through evolutionary time. For early humans, the night was genuinely dangerous. Predators hunted in the dark. Rival groups posed threats. The inability to move, the feeling of being stalked, these were real dangers. The brain's response to sleep paralysis taps into these ancient fears. The mechanisms that generate the experience evolved in a world where vigilance during vulnerable moments was essential for survival. The shadow figure, the sense of presence, the feeling of malevolence, these are the echoes of threats that once were real. Understanding sleep paralysis reduces its power. Knowledge does not eliminate the experience, but it changes how it is interpreted. When a person knows that the paralysis is temporary, that the hallucinations are generated by the brain, that no actual danger is present, the fear, though still present, is less overwhelming. The mind can hold two truths simultaneously. This feels terrifying, and I am safe. This dual awareness allows for a degree of emotional regulation that is not possible when the experience is entirely mysterious. Education about sleep paralysis, awareness of its causes and mechanisms, these are tools that diminish the hold the experience has over those who suffer from it. The experience fades not all at once, but gradually. Immediately after an episode, the memory is sharp, the emotions raw. Hours later, the intensity has diminished. Days later, it becomes a story, an event that happened rather than something currently happening. Weeks later, the details may blur, though the core memory remains. The brain processes the event, integrates it into the broader narrative of experience, and files it away. For some, it becomes a curiosity, an interesting neurological event. For others, it remains a source of unease, a reminder of vulnerability. The lasting impact varies, shaped by personality, prior experiences, and the frequency of episodes. When the brain reasserts control over the body, when movement returns and the hallucinations dissolve, there is a sense of the system rebooting. The connections between intention and action are restored. The muscles respond. The world becomes predictable again. The transition is not always smooth. There may be moments of disorientation, a lingering sense of unreality, a need to verify that one is truly awake. The person may look around the room, checking for inconsistencies, making sure that the environment is as it should be. This verification process is the brain's way of confirming that it has fully transitioned out of the liminal state and back into normal waking consciousness. The return to wakefulness after sleep paralysis is often accompanied by a complex mix of emotions. Relief is primary, the overwhelming gratitude that the ordeal is over. But there is also residual fear, a lingering unease, a heightened sensitivity to shadows and sounds. The body may feel fatigued, the adrenaline surge leaving behind a sense of exhaustion. The mind may be racing, replaying the experience, trying to make sense of it, trying to reassure itself that it is over. Sleep, which moments before was the state the person occupied, now feels distant and unwelcome. The thought of closing the eyes and returning to sleep may be accompanied by anxiety. a fear that the paralysis will return. Some people choose to stay awake for a while, to fully ground themselves in wakefulness before attempting to sleep again. The body's reboot after an episode involves the restoration of normal neuromuscular function. The inhibitory signals are withdrawn, the motor neurons are released from suppression, and the voluntary control of muscles is fully restored. The heart rate, which may have spiked during the episode, gradually returns to baseline. The breathing, which felt constrained, becomes deep and regular again. The stress hormones circulating in the bloodstream are metabolized and cleared. The body returns to its equilibrium, the state of calm that precedes sleep. This process takes time, minutes to tens of minutes, during which the person may remain alert, vigilant, ensuring that the paralysis does not return. The mind interprets safety through a combination of sensory input and cognitive appraisal. Once movement is restored, the person can verify through action that they are in control. They can turn on a light, sit up, look around, touch objects, hear their own voice. These actions confirm that the world is as it should be, that the rules of reality are intact. The cognitive appraisal follows. This was sleep paralysis, a known phenomenon, a temporary state, not a supernatural event, not a sign of danger. The rational mind reasserts itself, providing context and explanation. The fear, though it may linger, is no longer fed by ambiguity. The event is framed, understood, and thus made less threatening. The experience of sleep paralysis, though distressing, is not dangerous in itself. It does not cause physical harm. The heart may race, but it is not damaged. The breathing may feel restricted, but adequate oxygen reaches the brain. The paralysis is temporary and always resolves. The hallucinations, though terrifying, are not real. There is no intruder, no entity, no physical threat. The danger, such as it is, lies in the psychological impact, the fear, the anxiety, the potential for the experience to disrupt sleep and, by extension, well-being. But the event itself, the moment of paralysis and hallucination, is a benign neurological phenomenon, a quirk of the sleep-wake transition, nothing more. Understanding this, truly internalizing it, is transformative. It does not make the experience pleasant, but it removes the layer of existential dread that often accompanies it. The person is no longer left wondering if they're losing their mind, if they're under attack, if something is fundamentally wrong. They know what happened. They know why it happened. They know it will end. This knowledge is a form of control, a way to reclaim power over an experience that feels overwhelmingly disempowering. It is the difference between being a helpless victim of an inexplicable event and being an informed observer of a biological process. The slow return to calm after an episode is a process of de-escalation. The body's stress response is a powerful system designed to mobilize resources in the face of threat, but it cannot be sustained indefinitely. Once the perceived threat is gone, the parasympathetic nervous system takes over, initiating the relaxation response. Heart rate slows, breathing deepens, muscles relax. The mind, no longer flooded with fear, begins to settle. Thoughts become more coherent. The sense of time normalizes. The room, which moments before felt hostile and strange, becomes familiar again. The bed is just a bed. The shadows are just shadows. The silence is just silence. The experience dissolves, not abruptly, but gradually like fog lifting. The vividness fades. The certainty of the hallucinations weakens. The person begins to question what they saw, what they felt, not because the memory is gone, but because the emotional intensity that gave it such weight has diminished. In the light of full wakefulness, with rational thought restored, the experience is placed in context. It was sleep paralysis. It was a product of the brain, not an intrusion from outside. It was frightening, but it was not real. This reframing is essential for recovery, for the ability to return to sleep without overwhelming fear. The brain, having passed through this liminal state, having encountered the boundary between sleep and waking in such a direct way, returns to its ordinary functioning. The systems that maintain consciousness, that regulate sleep, that process perception and emotion, all resume their normal operations. The event is logged in memory, filed away with the emotional tag that marks it as significant. But life continues. The night passes. Morning comes. The person wakes, perhaps feeling tired, perhaps feeling unsettled, but intact. The experience, however strange, did not break anything. The mind remains whole. The body remains functional. The capacity to sleep, to dream, to wake, all remain intact. Sleep paralysis, in the end, is a window into the complexity of the brain, a reminder that consciousness is not a monolith, but a patchwork of systems that usually, but not always, work in seamless coordination. It is a glimpse of the machinery, a moment when the curtain is pulled back and the processes that are normally invisible become momentarily perceptible. It is unsettling precisely because it reveals how much of what is experienced as reality is constructed, interpreted, generated by the brain itself. The external world provides input, but the brain creates the experience. And when the brain is in a transitional state, when the systems are not fully aligned, the experience can become strange, surreal, frightening. But it is also, in its own way, a testament to the brain's adaptability, its capacity to generate meaning even in ambiguity, to protect the body even when the mind is disoriented. The paralysis that prevents injury during dreams, the threat detection systems that remain vigilant even in sleep, the construction of narrative to make sense of confusion. All of these are features, not flaws. They serve a purpose. They kept ancestors alive. They continue to serve, even if, in the modern world, their activation in the context of sleep paralysis feels more like a malfunction than a protection. The experience is deeply human. It is shared across time and culture. It is written into the structure of the brain, a potential that exists in everyone, though not everyone will encounter it. For those who do, it is a profound encounter with the hidden aspects of the self, with the parts of the mind that operate below the surface, that generate experience without conscious input. It is humbling. It is strange. It is, in its way, a reminder of the mystery that persists even in the most studied and mapped regions of human biology. The brain is known, but it is also, in many ways, still unknown. Sleep paralysis is one of the places where the unknown becomes briefly, vividly, undeniably present. And so the explanation unfolds layer upon layer, revealing the mechanics, the chemistry, the evolutionary history, the psychology, the phenomenology. Each layer adds depth, context, understanding. The fear that accompanies sleep paralysis is not irrational. It is the product of ancient systems doing what they were designed to do. The hallucinations are not random. They're the brain's attempt to create coherence in the face of sensory chaos. The paralysis is not a prison. It is a protective mechanism temporarily made visible. The experience, though it feels personal and targeted, is universal, a feature of the human condition. Understanding all of this does not make sleep paralysis pleasant. It does not eliminate the fear entirely, but it changes the relationship to the experience. It transforms it from an inexplicable, malevolent intrusion into a comprehensible, if uncomfortable, biological event. It shifts the experience from the realm of the supernatural to the realm of the natural, from the mysterious to the known. And in that shift, there is power. There is the power to endure, to recover, to sleep again without overwhelming dread. There is the power to recognize that the mind, for all its capacity to generate terror, is also capable of understanding, of learning, of adapting. The experience of sleep paralysis, when viewed through the lens of neuroscience, becomes a story about the brain's complexity, its strengths, and its vulnerabilities. It is a story about the thin line between sleep and waking, between dream and reality, between safety and threat. It is a story that has been told, in one form or another, for as long as humans have slept and woken and tried to make sense of the strange experiences that occur in the borderlands of consciousness. And it is a story that continues, each person who experiences it adding their own chapter, their own encounter with the hidden workings of the mind. The night deepens. The explanation continues, spiraling through the details, revisiting concepts, adding nuance. The brain's construction of reality is a constant process, a river that flows without pause. Perception, memory, emotion, thought, all are streams feeding into that river. Sleep paralysis is a moment when the flow is disrupted, when the streams become turbulent, when the construction of reality becomes visible in its raw form. It is disorienting, but it is also illuminating. It reveals that what is experienced as solid, stable, and objective is actually fluid, constructed, and subjective. The room is real, but the presence is not. The body is real, but the paralysis is temporary. The fear is real, but the threat is not. This distinction between what is real and what is constructed is at the heart of the sleep paralysis experience. The brain does not have direct access to the external world. It receives signals, light waves, sound waves, pressure on the skin, and from these signals, it constructs a model of reality. Most of the time, this model is accurate enough to navigate the world successfully. But it is always a model, an approximation, a best guess. During sleep paralysis, the model is distorted by the remnants of the dream state, by the heightened activity of the amygdala, by the absence of movement. The result is a model that includes elements that do not exist in the external world, but feel as real as anything that does. The philosophical implications of this are profound, though they are not the focus here. What matters, in the context of sleep paralysis, is that the person experiencing it can learn to distinguish between the model and the reality, between the feeling and the fact. The presence feels real, but it is not. The threat feels imminent, but it is not. The suffocation feels urgent, but the body is receiving adequate oxygen. These distinctions are difficult to hold in the moment, when the emotional systems are dominant and the rational systems are suppressed, but they can be learned, reinforced, internalized over time. And with that learning comes resilience. Resilience in the face of sleep paralysis is not about eliminating the experience, but about reducing its impact. It is about shortening the duration of fear, speeding the return to calm, preventing the anticipatory anxiety that can perpetuate the cycle. Techniques such as controlled breathing, mental reminders that the experience is temporary, and efforts to remain calm rather than struggling against the paralysis can all help. The struggle to move, the frantic attempts to break free, these often intensify the fear and prolong the episode. Acceptance, paradoxically, can lead to a quicker resolution. When a person stops fighting, when they allow the experience to run its course with the knowledge that it will end, the fear decreases, and the transition out of paralysis often happens more smoothly. This is not to say that acceptance is easy. The instinct to struggle, to fight, to escape is powerful and deeply rooted. But over time, with repeated experiences and growing understanding, some people develop the ability to recognize the onset of sleep paralysis and respond with calm rather than panic. They remind themselves, this is sleep paralysis, it is temporary, I am safe. This internal dialogue, though it does not stop the paralysis or the hallucinations, changes the emotional tone. Fear is replaced, at least partially, by curiosity or resignation. The experience is still unpleasant, but it is no longer catastrophic. The role of education in reducing the impact of sleep paralysis cannot be overstated. For someone who has never heard of the phenomenon, the first experience is completely baffling. It does not fit into any existing framework. It feels unique, inexplicable, possibly dangerous. The person may wonder if they're having a medical emergency, if they're experiencing a psychological breakdown, if something supernatural is occurring. All of these interpretations amplify fear. But when someone has been educated about sleep paralysis, when they know it is a common, well-documented phenomenon, the first experience, while still frightening, is at least comprehensible. The person can think, this might be sleep paralysis. This is what people describe. It will pass. This framework reduces the sense of helplessness and provides a path forward. For those who experience sleep paralysis frequently, education is even more critical. It transforms the experience from a recurring nightmare into a manageable inconvenience. It allows the person to take steps to reduce frequency, improving sleep hygiene, managing stress, avoiding sleep deprivation, adjusting sleep position. It provides a vocabulary to describe the experience to others, which can reduce the sense of isolation. Many people who experience sleep paralysis believe they are alone in it, that no one else would understand. Learning that it is common, that millions of people have experienced it, that it has been studied and documented, this can be profoundly reassuring. The sense of isolation is one of the more insidious aspects of sleep paralysis. The experience is intensely personal, occurring in the privacy of one's own mind and bedroom. It is not something that can be easily shared or verified. There are no visible signs, no external evidence. The person may hesitate to talk about it, fearing disbelief or ridicule. This silence can allow fear and confusion to fester. When the silence is broken, when the person learns that others have had the same experience, the isolation dissolves. The experience is validated. It is real, even if the hallucinations were not. This validation is healing. The neurological basis of sleep paralysis also helps to dispel the stigma that might otherwise surround it. It is not a sign of weakness, insanity, or spiritual vulnerability. It is a neurological event, a temporary desynchronization of the systems that regulate sleep and waking. It can happen to anyone. It does not reflect on character, mental health, or moral standing. This understanding is important not only for those who experience it, but for those around them. Friends, family, and healthcare providers who understand sleep paralysis can offer support and reassurance rather than dismissing the experience or, worse, feeding into supernatural or pathological interpretations. There's also a distinction to be made between sleep paralysis and other sleep disorders or psychological conditions. Sleep paralysis is not the same as a panic attack, though the physical sensations may be similar. It is not the same as a nightmare, though both can be frightening. It is not a symptom of schizophrenia or other psychotic disorders, though the hallucinations can be vivid. It is its own phenomenon, with its own specific causes and characteristics. Confusing it with other conditions can lead to misdiagnosis and inappropriate treatment. Clarity in diagnosis ensures that those who experience sleep paralysis receive the correct information and support. The experience of sleep paralysis also intersects with the broader human fascination with the liminal, the in-between, the threshold. Humans are drawn to boundaries between day and night, life and death, waking and sleeping, the known and the unknown. These boundaries are places of power and mystery in myth and folklore. Sleep paralysis is a literal crossing of one such boundary, a moment when the person is neither fully asleep nor fully awake. It is no surprise that the experience has been woven into cultural narratives, that it has been interpreted through spiritual and supernatural lenses. The boundary is a place where the ordinary rules seem to suspend, where strange things can happen, where the veil between worlds is thin. Of course, the neuroscientific explanation strips away the supernatural, but does not strip away the sense of strangeness, the feeling that one has glimpsed something unusual. That strangeness is part of what makes sleep paralysis so memorable. It is not an ordinary experience. It is not like waking up from a normal dream. It is vivid, intense, and bizarre in a way that stands out from the flow of everyday life. The brain flags it as significant, worth remembering, worth trying to understand. And so the memory persists, often for years, sometimes for a lifetime. People remember their first episode of sleep paralysis in detail, even if it happened decades ago. They remember where they were, what they saw, how they felt. The memory is etched deeply because the emotional intensity at the time of encoding was so high. The persistence of the memory also means that the experience can be revisited, reinterpreted, and integrated over time. As understanding grows, as more is learned about the brain and sleep, the meaning of the memory can change. What was once terrifying and inexplicable can become interesting and comprehensible. The narrative shifts from "something attacked me" to "I experienced a fascinating neurological event." This shift does not erase the memory or the emotions attached to it, but it adds a new layer of interpretation, a new framework through which to view the past. The experience is recontextualized, and in that recontextualization, some of its power to disturb is diminished. For some, the experience of sleep paralysis can even become a point of curiosity, a phenomenon they wish to understand more deeply or even explore. There are individuals who, having learned that sleep paralysis is harmless, attempt to induce it intentionally as a gateway to lucid dreaming or out-of-body experiences. This is a niche pursuit, not something most people would be interested in, but it speaks to the fact that the experience, once understood, can be approached from different angles. What is terrifying in ignorance can become intriguing in knowledge. The brain's capacity for adaptation is remarkable. It can learn to fear sleep paralysis, but it can also learn to not fear it, or at least to fear it less. Repeated exposure, combined with the knowledge that no harm comes from the experience, can lead to habituation. The amygdala, which initially responds with intense alarm, can, over time, learn that this particular situation, though strange, is not dangerous. The fear response can be dampened. This is not guaranteed, and for some people, the fear remains intense no matter how many times the experience occurs. But for others, the terror of the first episode gives way to discomfort, then to annoyance, then to a sort of weary resignation. The experience is still unwelcome, but it no longer provokes panic. The reduction of fear through understanding and habituation is a principle that applies broadly, not just to sleep paralysis. The brain is a learning organ, constantly updating its models based on experience. When an experience repeatedly occurs without the predicted negative outcome, the fear associated with it decreases. This is the basis of exposure therapy for phobias and anxiety disorders. The same principle applies here. Sleep paralysis, experienced repeatedly without lasting harm, gradually loses its power to terrify, provided the person has the framework to understand what is happening. The question of why some people experience sleep paralysis and others do not is still not fully answered. There are risk factors, stress, sleep deprivation, irregular schedules, certain sleep disorders, but these do not fully account for the distribution of the experience. Some people who sleep poorly and live high-stress lives never experience it. Others who sleep well and live calm lives do. There is likely a genetic component, a variation in the brain's regulation of REM sleep and the transition between sleep stages. There may also be individual differences in the sensitivity of the systems involved, the motor inhibition, the amygdala response, the vividness of internally generated imagery. These differences mean that for some people, the conditions for sleep paralysis are more easily met, while for others, the brain transitions smoothly between sleep and waking without incident. This variability is a reminder that human brains, while sharing a common architecture, are not identical. Each brain is shaped by genetics, experience, environment, and chance. The result is a spectrum of experiences. Some people dream vividly every night and remember their dreams in detail. Others rarely remember dreaming. Some people experience sleep paralysis. Others never do. Neither is more correct or more normal. They are simply different points on the spectrum of human sleep experience. The diversity of experience also means that the strategies for managing sleep paralysis must be individualized. What works for one person may not work for another. For some, improving sleep hygiene, going to bed at the same time each night, reducing caffeine and alcohol, creating a calm sleep environment, significantly reduces the frequency of episodes. For others, managing stress through mindfulness, therapy, or exercise is key. For still others, changing sleep position from back to side makes a difference. And for some, no intervention seems to help, and they simply learn to endure and minimize the impact. There is no one-size-fits-all solution, but there are many tools available, and most people, through trial and adjustment, can find an approach that helps. The role of the mind in shaping the experience extends beyond the hallucinations themselves to the aftermath. how a person interprets the experience, how they talk about it, how they integrate it into their understanding of themselves. All of these influence the long-term impact. Someone who interprets sleep paralysis as a sign that they are vulnerable or broken may develop anxiety that persists beyond the episodes themselves. Someone who interprets it as an interesting quirk of neurology may experience little lasting distress. The narrative matters. The story one tells oneself about the experience shapes the emotional response and the degree of ongoing concern. This is why framing, education, and cognitive reappraisal are so important. They provide tools for constructing a narrative that is accurate, non-threatening, and empowering. The narrative is not, "Something is wrong with me." The narrative is, "My brain experienced a temporary desynchronization during the sleep-wake transition. This is a known phenomenon. It is not dangerous. It will pass." This narrative reduces fear, prevents rumination, and supports recovery. It is a narrative grounded in science and reinforced by understanding. The connection between sleep paralysis and the broader field of sleep research is also worth noting. Sleep is a complex, multi-stage process, and sleep paralysis is just one of many phenomena that can occur when that process is disrupted. Sleepwalking, sleep talking, night terrors, hypnagogic hallucinations, exploding head syndrome. All of these are examples of parasomnias, events that occur during sleep or at the boundaries of sleep. Each has its own mechanisms and characteristics, but they all illustrate the same fundamental point. Sleep is not a single, monolithic state, but a series of stages and transitions, each governed by different neural systems, and each vulnerable to disruption. Sleep paralysis is perhaps the most dramatic of these disruptions, but it is part of a larger picture. The study of sleep and its disorders has advanced significantly in recent decades. Polysomnography, the recording of brain waves, eye movements, muscle activity, and other physiological signals during sleep, has allowed researchers to map the stages of sleep with precision. Neuroimaging techniques have revealed which brain regions are active during each stage. Molecular biology has identified some of the neurotransmitters and genetic factors involved in sleep regulation. This growing body of knowledge has demystified many aspects of sleep, including sleep paralysis. What was once attributed to supernatural forces is now understood in terms of neurotransmitters, inhibitory neurons, and state-dependent activation patterns. The mystery has not entirely dissolved. There is still much to learn, but the framework is now biological rather than mystical. And yet, for all the scientific understanding, the subjective experience of sleep paralysis retains its strangeness. Knowing how and why it happens does not fully capture what it feels like to be trapped in one's own body, to be awake but unable to move, to see and hear things that are not there, to be gripped by fear that feels existential. The phenomenology, the lived experience, remains powerful and unsettling. This is a reminder that subjective experience and objective explanation, while related, are not the same. Understanding the brain does not erase the reality of the mind. The experience is real, even if the hallucinations are not. The history of human attempts to explain sleep paralysis is long and varied. In ancient Greece, it was attributed to the gods or to indigestion. In medieval Europe, it was blamed on demons, particularly the incubus and succubus, malevolent spirits said to sit on the chests of sleepers and cause suffocation. In many cultures, it was seen as a form of spiritual attack or possession. These explanations, while scientifically inaccurate, were attempts to make sense of a deeply disturbing experience. They provided a framework, however flawed, for understanding and, in some cases, for seeking protection or remedy. Rituals, prayers, and talismans were used to ward off the entities believed to cause the paralysis. These interventions may have provided psychological comfort, a sense of control in the face of helplessness. The transition from supernatural to scientific explanation has been gradual and is still not complete in all cultures. In some parts of the world, sleep paralysis is still interpreted through spiritual or supernatural lenses. These interpretations are deeply embedded in cultural belief systems and are not easily displaced by scientific information. Understanding this cultural context is important when discussing sleep paralysis in a global or cross-cultural setting. It is not enough to simply present the neuroscience. One must also respect and engage with the cultural narratives that give meaning to the experience for different people. At the same time, the scientific explanation has the advantage of being universal. It applies regardless of culture, belief, or geography. The mechanisms of REM sleep, the inhibition of motor neurons, the activation of the amygdala, these are features of the human brain shared by all people. The hallucinations may be shaped by culture, but the underlying process is the same. This universality is both a strength and a limitation. It provides a common ground for understanding, but it does not capture the full richness of how the experience is lived and interpreted in different contexts. The conversation about sleep paralysis, then, is a conversation that must bridge neuroscience and phenomenology, the objective and the subjective, the universal and the particular. It is a conversation that requires both precision and empathy, both data and narrative. The goal is not to dismiss the experience or to reduce it to mere biology, but to provide tools for understanding and coping, to reduce fear and suffering, to empower those who experience it with knowledge and support. As the explanation continues, it circles back to the central themes, reinforcing and deepening them. The paralysis is a protective mechanism. The hallucinations are the brain's attempt to make sense of ambiguity. The fear is a natural response to a perceived threat. The experience is temporary and not dangerous. Understanding reduces fear. Knowledge is a form of control. The brain is adaptable. The experience, though strange, is part of the human condition. These themes are repeated, varied, explored from different angles, because repetition aids understanding and because the complexity of the phenomenon warrants deep examination. The experience of sleep paralysis is also a reminder of the vulnerability inherent in the human condition. Sleep is a state of vulnerability. The body is still, the senses are dimmed, awareness is reduced. Throughout evolution, sleep has been necessary but dangerous. The sleeping organism is exposed to predators, to environmental hazards, to attack by rivals. The brain's vigilance, even in sleep, reflects this evolutionary history. The systems that generate sleep paralysis hallucinations are part of this vigilance, a last line of defense when the boundaries between sleep and waking blur. The experience is uncomfortable precisely because it touches on this fundamental vulnerability, this awareness that, in sleep, one is not fully in control. But vulnerability is not weakness. It is simply a fact of existence. All living things have periods of vulnerability, moments when defenses are lower, when help is needed, when threats loom larger. The ability to navigate vulnerability, to recover from frightening experiences, to learn and adapt, these are strengths. Sleep paralysis, for all its discomfort, does not cause lasting harm. The person wakes, recovers, and continues. The experience may leave a mark, but it does not define the person. Life goes on, sleep returns, and with knowledge and understanding, the fear diminishes. The slow unwinding of the explanation mirrors the slow unwinding of the experience itself. The initial shock, the peak of fear, the gradual return to calm, the integration of the event into memory. All of these phases are mirrored in the structure of understanding. First comes the raw description of what happens, the immediate and visceral. Then comes the explanation, the mechanisms, the neuroscience. Then comes the contextualization, the cultural and evolutionary perspective. Then comes the practical, the tools for managing and reducing impact. And finally comes the integration, the placing of the experience within the broader context of human life and consciousness. This layered approach is necessary because sleep paralysis is not a simple phenomenon. It is a convergence of multiple systems: motor control, sensory processing, emotion regulation, consciousness itself, all interacting in a moment of transition. To understand it fully requires looking at it from multiple angles, and even then, the full picture is elusive. There's always more to learn, more nuance to uncover, more individual variation to account for. But the core understanding, that sleep paralysis is a natural, temporary, and non-dangerous event caused by a desynchronization of sleep-wake systems. This core understanding is solid and well supported by evidence. The calm, slow pace of this explanation is intentional. It is designed to mirror the kind of tone that helps reduce fear, that allows the mind to settle, that creates space for understanding to take root. Panic thrives on urgency, on rapid escalation, on the sense that something must be done immediately. Calm thrives on patience, on the willingness to sit with discomfort, on the trust that understanding will come with time. This explanation is an exercise in patience, in the slow accumulation of knowledge, in the gentle dismantling of fear through clarity. And so the words continue, sentence after sentence, paragraph after paragraph, weaving together the science, the experience, the context, the history, the variability, the commonality, the strangeness, the ordinariness. Sleep paralysis is both extraordinary and mundane, both terrifying and harmless, both deeply personal and widely shared. It is a paradox, a tension, a moment when the hidden workings of the mind become briefly, startlingly visible. It is a teacher, in its way, offering lessons about the nature of consciousness, perception, fear, and resilience. It is a challenge, demanding that the person find ways to cope, to understand, to integrate the experience without being overwhelmed by it. And it is, ultimately, a part of the vast and intricate tapestry of human experience, one thread among many, strange but not alien, frightening but not insurmountable. The explanation does not seek to eliminate the mystery entirely. There is still much about consciousness, about the brain, about the nature of subjective experience that remains unknown. Sleep paralysis touches on these deeper mysteries, these questions about what it means to be awake, to be aware, to construct reality from the raw material of sensory input. These questions have occupied philosophers and scientists for centuries and will likely continue to do so. But within the scope of sleep paralysis, much is known, and that knowledge is sufficient to provide reassurance, to reduce fear, to offer practical guidance. The mystery that remains is not a frightening void, but a frontier, an invitation to continue learning and exploring. The experience of sleep paralysis, once integrated, becomes part of the person's story. It is an event that happened, a moment that was survived, a challenge that was met. For some, it becomes a minor footnote, barely remembered. For others, it remains a significant memory, a moment that revealed something about the nature of the mind and the fragility of the boundary between sleep and waking. Either way, it is part of the lived experience, part of the accumulation of moments that make up a life. And like all such moments, it carries meaning, whether that meaning is profound or trivial, whether it leads to insight or simply to a shrug. The body, having passed through the paralysis, having felt the restriction and then the release, carries its own memory. The muscles remember being unable to respond. The heart remembers racing. The lungs remember the struggle for breath. But the body also remembers recovery, the return to normalcy, the restoration of function. This bodily memory, though less conscious than the mental memory, contributes to the overall sense of the experience. The body knows, in its own way, that the paralysis ended, that movement returned, that the threat, such as it was, passed. This knowledge, though not articulated in words, provide the foundation for resilience. The mind and body are not separate, though it is sometimes useful to speak of them as if they are. They are aspects of a single, integrated system, each influencing the other continuously. The fear generated by the mind affects the body, heart rate, breathing, muscle tension. The sensations in the body affect the mind. The restricted breath fuels the narrative of suffocation. The inability to move fuels the narrative of being trapped. This loop, this constant interaction, is what makes sleep paralysis such a total experience, engaging both mind and body in a moment of intense, disorienting awareness. And it is also what makes recovery possible. As the body calms, the mind calms. As the mind understands, the body relaxes. The two support each other in the return to equilibrium. The night continues. The explanation continues. The details accumulate. The perspectives shift. The understanding deepens. Sleep paralysis is examined from every angle: neurological, psychological, evolutionary, cultural, phenomenological. Each angle reveals something new, adds another layer to the picture. The goal is not to repeat the same points endlessly, but to spiral around them, approaching them from different directions, adding depth and nuance with each pass. The reader, or listener, is invited into this slow, thorough exploration, encouraged to linger with each idea, to let the understanding build gradually rather than being presented all at once in a rushed summary. This approach respects the complexity of the subject and the intelligence of the audience. It does not oversimplify or condescend. It trusts that the listener can handle complexity, can follow a long and winding explanation, can appreciate the thoroughness. It also acknowledges that understanding is not always immediate. Sometimes an idea needs to be encountered multiple times from multiple angles before it truly sinks in. Repetition, when done with variation, reinforces learning. It creates multiple pathways to the same insight, increasing the likelihood that the insight will be retained and integrated. The experience of sleep paralysis, like any intense experience, is not easily forgotten, but its emotional charge can be reduced, its meaning can be reinterpreted, and its impact on future sleep can be minimized. This requires time, reflection, and, most importantly, accurate information. The brain is a storytelling organ, constantly constructing narratives to explain experience. When given accurate information, it constructs helpful narratives. When left in ignorance, it constructs unhelpful ones. The goal of this explanation is to provide the accurate information needed to construct a narrative that is both true and reassuring. The narrative is: sleep paralysis is a natural neurological event, temporary and harmless, caused by a temporary desynchronization of brain systems during the transition from sleep to waking. It can be frightening, but it is not dangerous. It can be understood, and understanding reduces fear. This narrative, once internalized, becomes a tool, a cognitive resource that can be drawn upon the next time sleep paralysis occurs, or when the fear of it arises, or when explaining it to someone else who has experienced it. It is a narrative that empowers rather than frightens, that clarifies rather than obscures, that connects the individual experience to the broader, shared human experience. And in that connection, there is comfort. The person is not alone. Others have been here. Others have understood. Others have moved through this and continued on. The fabric of human experience is woven from countless threads, each representing a different kind of moment, a different kind of feeling, a different kind of understanding. Sleep paralysis is one thread, a dark one perhaps, but still part of the whole. It does not dominate the tapestry, but it is there, a reminder of the complexity of consciousness, the intricacy of the brain, the strangeness that can emerge in the liminal spaces of existence. To understand this thread, to see how it fits into the larger pattern, is to gain insight not just into sleep paralysis, but into the nature of being human, vulnerable, resilient, capable of fear, capable of understanding, forever navigating the boundary between the known and the unknown, between sleep and waking, between the mind's construction and the world's reality. And with that understanding, the explanation comes to rest, not with a conclusion, but with a quiet settling, a sense that enough has been said, enough has been explored. The voice fades, the thoughts quiet, and the listener is left with knowledge, with tools, with a framework for understanding an experience that, though strange, is no longer inexplicable. The mystery has not been entirely dispelled. Consciousness itself remains mysterious, but the specific mystery of sleep paralysis has been illuminated, and in that illumination, there is peace. Sleep paralysis is a state in which the body remains frozen while the mind becomes conscious, caught in the narrow passage between sleep and waking. It is not a dream, though it shares qualities with dreaming. It is not full wakefulness, though awareness feels sharp and present. It exists in the thin border where two states of being overlap, where the machinery of sleep has not yet released its hold, and the mind finds itself awake inside a body that will not respond. The human brain cycles through stages of sleep throughout the night, descending into deeper layers of rest before rising again toward the surface. One of these stages is called REM sleep, named for the rapid eye movements that occur beneath closed lids during this phase. REM sleep is where most vivid dreaming happens. It is also the stage in which the brain initiates a process called atonia, a temporary paralysis of nearly all voluntary muscles in the body. This paralysis is not accidental. It serves a protective function, preventing the body from acting out the movements that occur in dreams. Without this mechanism, a person dreaming of running might thrash their legs, or someone dreaming of fighting might strike out with their fists. Atonia keeps the body still while the mind wanders through imagined landscapes. During typical REM sleep, consciousness is submerged. The dreaming mind does not realize it is dreaming. The paralysis goes unnoticed because awareness itself is wrapped inside the dream. But sometimes, the process does not unfold smoothly. The mind can wake while the body remains locked in atonia. Consciousness surfaces too early before the paralysis has lifted. This is sleep paralysis. The person becomes fully aware of their surroundings, their bed, their room, the darkness or dim light filtering through a window, but they cannot move. The arms will not lift. The legs will not shift. The head will not turn. Even the voice often refuses to function, leaving the person unable to call out or make more than a strained sound. This immobility is not caused by physical injury or external force. It is the brain's own doing, a lingering effect of the chemical signals that suppress muscle activation during REM sleep. The motor cortex, the region of the brain responsible for voluntary movement, remains inhibited. The neurons that would normally send commands to the muscles are dampened, their signals blocked by neurotransmitters that enforce stillness. The body is obeying an instruction that is no longer appropriate, continuing to follow orders meant for a sleeping mind. The experience can last anywhere from a few seconds to several minutes, though time perception during sleep paralysis is often distorted. Seconds can feel like minutes. The inability to move creates a sense of urgency, and urgency stretches time. The mind, fully awake and alert, races through thoughts and sensations while the body remains unresponsive. This disconnect between mind and body can trigger intense confusion and fear, especially for those experiencing it for the first time. Fear is not merely a byproduct of sleep paralysis. It is woven into the experience by the brain's own architecture. The amygdala, a small almond-shaped structure deep within the brain, plays a central role in processing fear and threat detection. During sleep paralysis, the amygdala remains highly active, operating in a mode more typical of REM sleep than waking consciousness. In dreams, the amygdala helps generate emotional content, often leaning towards scenarios involving danger, pursuit, or conflict. When a mind wakes during atonia, the amygdala does not immediately switch to its waking mode. It continues to interpret the situation through a lens colored by the logic of dreaming, where threats feel imminent and danger seems present even when it is not. The inability to move amplifies this fear response. The brain interprets paralysis as a sign of danger. In evolutionary terms, being unable to flee or defend oneself is a condition associated with extreme vulnerability, such as being trapped by a predator or caught in a life-threatening situation. The amygdala responds accordingly, flooding the system with signals that heighten alertness and prime the body for survival. But the body cannot respond. The muscles remain locked. The mismatch between the fear response and the inability to act intensifies the sensation of dread. This fear does not exist in isolation. It shapes perception itself. The mind, awake but still partially submerged in the neural environment of REM sleep, begins to generate sensory experiences that match the emotional tone set by the amygdala. Hallucinations emerge, not as intentional imaginings, but as automatic constructions of a brain trying to make sense of its own state. These hallucinations can be visual, auditory, or tactile. They are not merely imagined in the way a daydream is imagined. They are perceived with the same vividness and immediacy as real sensory input, indistinguishable in the moment from actual events occurring in the room. Visual hallucinations during sleep paralysis often take the form of shadowy figures. A dark shape may appear at the edge of the bed, standing in a doorway, or moving slowly across the room. The figure is usually indistinct, lacking clear features, though sometimes it seems to have a vague human form. The shadow may appear to watch, to approach, or simply to be present in a way that feels menacing. The brain, attempting to explain the overwhelming sense of threat generated by the amygdala, projects that threat into the environment. It creates a visual representation of the danger it believes is present, even though no actual danger exists. Other common visual hallucinations include distortions of the room itself. Walls may seem closer or farther away. The ceiling may appear to shift or warp. Objects in a room might seem altered in size or position. These distortions occur because the brain is combining fragmented input from the waking senses with the internally generated imagery typical of REM sleep. The result is a hybrid perception, neither fully dream nor fully waking, where the familiar becomes strange. Auditory hallucinations are equally common. People report hearing footsteps, whispers, breathing, or rustling sounds. Voices may speak in low tones, sometimes seeming to come from the shadowy figure, sometimes from an unseen source. The words, if discernible, are often vague or unsettling. Mechanical sounds are also reported: buzzing, humming, static, or a low droning noise that seems to vibrate through the air. These sounds are constructed by the auditory cortex in response to the same mismatch between expectation and reality. The brain anticipates sound in the environment, particularly threatening sound, and in the absence of actual auditory input, it manufactures its own. Tactile hallucinations involve the sensation of being touched, pressed, or held down. One of the most frequently reported experiences is the feeling of pressure on the chest, as though a heavy weight is pressing down, making it difficult to breathe. This sensation has been described across cultures and throughout history. It is so consistent that it has given rise to various mythological explanations, from demons sitting on the chest to malevolent spirits attempting to suffocate the sleeper. The actual cause is far more mundane. During REM sleep, breathing patterns change. The diaphragm and intercostal muscles, which control breathing, operate differently than during waking life or non-REM sleep. When consciousness returns during atonia, the person becomes aware of these altered breathing patterns. The sensation of restricted or shallow breathing, combined with the fear response, is interpreted as external pressure. The brain, seeking an explanation, attributes the sensation to a physical force, and the hallucination of weight on the chest solidifies. Other tactile hallucinations include the feeling of being grabbed, pulled, or dragged. Some people report the sensation of hands touching their arms, legs, or face. Others describe a feeling of being choked or held down by invisible force. These sensations are not imagined in the sense of being consciously fabricated. They are felt as real physical contact, generated by the somatosensory cortex as part of the brain's attempt to construct a coherent narrative from the conflicting signals it is receiving. The most disturbing aspect of sleep paralysis for many people is the sensation of a presence in the room. This is not necessarily a visual hallucination, though it often accompanies one. It is a distinct feeling that someone or something is nearby, watching, waiting, or intending harm. This presence feels undeniable, more certain than mere suspicion. It is as though the person can sense the entity with a form of perception that bypasses normal sight or hearing. The feeling is so strong that even after the paralysis ends, and the person can move and look around, the conviction that something was there often persists. This sensation of presence is not unique to sleep paralysis. It can occur in other conditions as well, such as certain neurological disorders, extreme fatigue, or sensory deprivation. The brain contains networks dedicated to detecting the presence of other beings, particularly other humans. These networks are part of the social brain, the collection of neural systems that help us navigate interactions with others, predict their intentions, and respond to their actions. The temporoparietal junction, a region involved in distinguishing self from other, plays a key role in generating the sense that another being is present. During sleep paralysis, this region can become active in the absence of any actual person, producing the sensation that someone is nearby. The reason this sensation leans toward menace rather than comfort is again tied to the amygdala and the brain's threat detection systems. The context of paralysis and fear primes the brain to interpret ambiguous information as dangerous. The presence is not neutral. It is assumed to be hostile because the emotional state makes hostility the most salient interpretation. The brain does not generate a comforting presence because comfort does not align with the physiological state of heightened alertness and frozen immobility. The consistency of these hallucinations across different people, cultures, and historical periods is striking. Descriptions of sleep paralysis from medieval Europe, ancient China, modern North America, and rural Africa share common elements. The inability to move, the sense of a malevolent presence, the pressure on the chest, the shadowy figure. This universality is not evidence of a supernatural phenomenon. It is evidence of shared human neurobiology. All human brains are built according to the same basic blueprint. The neural circuits that produce fear, the sensory systems that construct perception, the mechanisms that regulate sleep and muscle tone. These are the same across the species. When these systems malfunction or overlap in specific ways, they produce similar experiences regardless of culture or belief system. Historical interpretations of sleep paralysis varied widely depending on the prevailing worldview of the time and place. In medieval Europe, the experience was often attributed to demons or witches. The term nightmare originally referred not to a bad dream, but to a night hag, a malevolent spirit believed to sit on the chests of sleepers and cause suffocation. In Newfoundland, the phenomenon was called the old hag. In Japanese culture, it was associated with a vengeful spirit or demon pressing down on the sleeper. In some African and Caribbean cultures, it was linked to spiritual attack or the influence of malevolent entities. These explanations were not arbitrary. They were attempts to make sense of a terrifying and inexplicable experience using the conceptual tools available at the time. The language and imagery of spirits and demons provided a framework for understanding something that had no clear physical cause. Modern neuroscience offers a different framework. The hallucinations, the paralysis, the fear, all of these are products of the brain's own activity, misfiring in a specific and predictable way. The supernatural explanations were wrong in their conclusions, but understandable in their reasoning. When the body refuses to move and a shadowy figure appears to loom over the bed, attributing the experience to an external malevolent force is a natural human response. It is the same cognitive process that leads people to see patterns in randomness or to attribute intention to events that are coincidental. The brain is a meaning-making machine. It does not tolerate ambiguity well. When faced with an experience that defies normal explanation, it reaches for the most emotionally resonant narrative available. The feeling that sleep paralysis is somehow connected to something ancient or primal is not entirely unfounded, though the connection is neurological rather than mystical. The fear response activated during sleep paralysis is indeed ancient in evolutionary terms. The amygdala and related structures evolved hundreds of millions of years ago, long before humans existed. These systems are designed to detect and respond to threats with speed and efficiency, often bypassing conscious thought. The visceral terror experienced during sleep paralysis is the same kind of fear a prey animal feels when it senses a predator nearby. It is not a calm, rational assessment of danger. It is an overwhelming, whole-body alarm that demands immediate action. The tragedy of sleep paralysis is that immediate action is impossible. The body is locked in place, and the fear can only intensify with no outlet for release. Stress, anxiety, and irregular sleep patterns increase the likelihood of experiencing sleep paralysis. When the body is exhausted or the sleep schedule is disrupted, the transitions between sleep stages become less smooth. The brain may enter REM sleep more abruptly or wake from it prematurely. People who work night shifts, who travel across time zones frequently, or who suffer from chronic sleep deprivation are more prone to episodes. Anxiety and stress do not directly cause sleep paralysis, but they disrupt the normal architecture of sleep, making the delicate timing of REM transitions more prone to error. The mind that is already primed for vigilance and worry is also more likely to experience the hallucinations of sleep paralysis as intensely threatening. Sleep position also plays a role. Many people report that sleep paralysis occurs more frequently when they sleep on their backs. The reason for this association is not entirely clear, but it may relate to airway resistance and breathing patterns. Sleeping on the back can lead to partial airway obstruction in some individuals, altering the sensation of breathing and potentially triggering awareness during REM sleep. The chest pressure hallucination may also be more likely in this position, as the weight of the chest itself pressing down against the mattress creates a subtle sensation that the dreaming mind amplifies into something external and threatening. The duration of an episode is usually brief, though it does not feel brief while it's happening. Most episodes last between 20 seconds and 2 minutes. In rare cases, they can extend longer, but the paralysis always ends. The brain does not remain stuck in this state indefinitely. The chemical signals that maintain atonia eventually dissipate, and the motor cortex regains its ability to send commands to the muscles. The person may regain movement gradually, with fingers or toes twitching first, or the paralysis may lift all at once, allowing sudden movement. Often, the episode ends when the person manages to focus intensely on moving a single part of the body, a finger, a toe, the jaw, and that small movement breaks the hold of the paralysis, allowing the rest of the body to follow. Some people learn to recognize sleep paralysis as it begins and can short-circuit the fear response by reminding themselves that the experience is temporary and harmless. This requires a degree of familiarity with the phenomenon and a capacity to remain calm in the face of instinctive terror. It is not easy. The fear generated during sleep paralysis is not the product of conscious thought that can be reasoned away. It is deeper, more automatic, rooted in systems that do not respond well to logic. But repeated experience can sometimes reduce the intensity of the fear. The brain learns, over time, that the hallucinations are not real, that the paralysis will end, and that no harm comes from the experience. This learning does not prevent future episodes, but it can make them less distressing. The relationship between expectation and experience in sleep paralysis is significant. People who have heard about sleep paralysis, who know what to expect, often report less fear during episodes. Conversely, those who have no prior knowledge may interpret the experience through cultural or religious frameworks that increase terror. If a person believes in demonic possession or spiritual attack, an episode of sleep paralysis may seem like confirmation of those beliefs, reinforcing fear and making future episodes more likely to be interpreted through the same lens. The mind does not experience the hallucinations as neutral sensory data. It interprets them, and the interpretation shapes the emotional response. This interpretive flexibility is also why the specific details of hallucinations can vary somewhat between individuals and cultures, even as the core elements remain consistent. The shadowy figure might resemble a cultural archetype, a witch, a demon, an alien, a ghost, depending on what images are most salient in the person's mental landscape. The brain draws on available imagery to flesh out the vague, threatening presence it senses. The underlying neural process is the same, but the surface details are customized by personal and cultural context. Time distortion during sleep paralysis is a consistent feature. Seconds stretch into what feels like minutes. A 2-minute episode might feel like 10 or 15 minutes of subjective time. This distortion occurs because the brain's timekeeping mechanisms are not functioning normally. The neural circuits that track the passage of time rely on regular input from the body and the environment. Movement, sensory change, the rhythm of breathing and heartbeat. During sleep paralysis, many of these inputs are absent or altered. The body is still. The environment is unchanging. Breathing feels restricted. The brain, lacking its usual cues, struggles to accurately gauge duration. Fear also plays a role. Emotional arousal is known to distort time perception. Moments of intense fear are often remembered as lasting longer than they actually did. The brain, hyper-focused on the threat, processes more information per unit of time, creating a memory that feels stretched. Breathing during sleep paralysis feels labored and insufficient, though actual respiration is usually adequate. The sensation of suffocation or inability to draw a full breath is largely perceptual. During REM sleep, the muscles involved in voluntary breathing are partially inhibited, just like other skeletal muscles. Breathing continues automatically, regulated by the brainstem, but the conscious control over deep breaths or rapid breathing is reduced. When awareness returns during atonia, the person notices this lack of control and interprets it as difficulty breathing. The chest pressure hallucination compounds the sensation, creating the feeling that something is preventing air from entering the lungs. Panic can further disrupt breathing patterns, leading to shallow, rapid breaths that feel even more inadequate. The feedback loop between perception and fear tightens, making the sensation of suffocation more intense. The brain's interpretation of ambiguous or incomplete information during sleep paralysis follows a principle common to perception in general. The mind fills in gaps based on expectation and context. When sensory input is unclear or conflicting, the brain does not wait for more information. It guesses. It constructs a best estimate of what is happening based on prior experience and current emotional state. During sleep paralysis, the emotional state is one of fear and vulnerability. The sensory input is ambiguous, dim light, indistinct shadows, muffled sounds, the sensation of immobility. The brain's best guess, given these conditions, is that danger is present. It fills in the details accordingly, creating hallucinations that match the expectation of threat. This process is not conscious fabrication. It happens automatically below the level of awareness. The person does not decide to see a shadowy figure or hear footsteps. These perceptions arise unbidden, with the same sense of reality as any other sensory experience. The boundary between perception and hallucination is not as clear as it might seem. All perception involves a degree of construction. The brain takes raw sensory data, photons hitting the retina, vibrations reaching the eardrum, and transforms them into coherent experiences of sight and sound. During sleep paralysis, the construction process goes awry. The brain generates experiences that have no external source, but it does so using the same mechanisms it uses to process real sensory input. This is why the hallucinations feel indistinguishable from reality in the moment. Memory of sleep paralysis episodes tends to be vivid and persistent. People often remember their first episode in great detail, even years later. The intensity of the fear and the strangeness of the experience etch it into memory. The amygdala, which is so active during the episode, also plays a key role in memory consolidation, particularly for emotionally charged events. Memories associated with strong emotions are prioritized, encoded more deeply than mundane experiences. This is an adaptive feature under normal circumstances, allowing the brain to remember dangers and avoid them in the future. But in the case of sleep paralysis, the memory serves no protective function. The danger was not real, and there is no behavior that can prevent future episode from occurring. The vivid memory simply reinforces the sense that something significant and disturbing happened. The personal quality of the experience the feeling that it was directed specifically at the individual, is another aspect of how the brain constructs meaning. The presence in the room does not feel like a random occurrence. It feels intentional, as though the entity is there for the person, focused on them with malevolent purpose. This sense of being targeted arises from the same neural systems that help us understand social interactions. Humans are deeply attuned to the intentions of others. The ability to infer what another person is thinking or planning is crucial for social survival. But this ability can misfire. During sleep paralysis, the brain senses a presence and automatically attributes intention to it. The presence is not neutral. It is watching, waiting, threatening. The mind cannot help but read intention into the ambiguous stimulus, and because the emotional context is one of fear, the inferred intention is hostile. The difference between sleep paralysis hallucinations and ordinary dreams is significant. Dreams occur during sleep when consciousness is submerged. The dreamer does not question the reality of the dream while it is happening. Logic is suspended. Impossible events seem normal. Upon waking, the dream is recognized as unreal, and memory of it often fades quickly. Sleep paralysis, by contrast, occurs when the mind is awake. The person is aware of their actual surroundings, lying in their bed, unable to move. The hallucinations occur within this waking awareness, overlaid on the real environment. There is no dream narrative, no sequence of events, no sense of being transported to another place. The person knows they are in their room, and the hallucinations intrude into that reality. This makes them far more disturbing than even the most vivid nightmare. A nightmare, once recognized as a dream, loses its power. Sleep paralysis hallucinations, experienced while awake, resist that easy dismissal. Some people experience overlap between sleep paralysis and lucid dreaming. Lucid dreaming is the state of being aware that one is dreaming while the dream is still happening. From a neurological perspective, lucid dreaming and sleep paralysis share certain features. Both involve a hybrid state of consciousness, where elements of waking awareness coexist with elements of REM sleep. In lucid dreaming, the awareness emerges within the dream, allowing the dreamer to recognize the dream state and sometimes exert control over the dream content. In sleep paralysis, the awareness emerges into waking reality, but the hallucinations of REM sleep persist. Some people who practice lucid dreaming techniques report that sleep paralysis episodes can serve as a gateway into lucid dreams if they can relax and allow the transition back into sleep rather than fighting the paralysis. This requires a level of comfort with the experience that most people do not have. The vividness of sleep paralysis, the intensity of the sensory experiences and emotions, often surpasses that of ordinary dreams. This is likely because the waking components of the brain are active and engaged. During a normal dream, consciousness is dim and memory encoding is weak. Most dreams are forgotten within minutes of waking. But during sleep paralysis, the hippocampus and other memory structures are functioning at waking levels. The experience is encoded as a waking memory, not a dream memory. The sensory cortices are also processing information more actively, creating hallucinations that are sharper and more detailed than dream imagery. The result is an experience that feels hyperreal, more vivid than everyday perception. The transition back to full waking control is not always smooth. After the paralysis lifts, the person may feel disoriented, shaky, or anxious. The body may feel strange, as though it is not quite under full control. The heart may be racing, breathing rapid. These are the aftereffects of the fear response, the lingering activation of the sympathetic nervous system. It can take several minutes for the body to return to a calm baseline. Some people are afraid to go back to sleep immediately, fearing the paralysis will return. This fear can contribute to insomnia and further disrupt sleep patterns, increasing the likelihood of future episodes. The brain's process of reasserting control after sleep paralysis is gradual. The motor cortex must fully disengage from the inhibitory signals that held it in check. The neurotransmitters that enforced autonia must be cleared from the synapses, allowing normal motor commands to flow. The prefrontal cortex, the region responsible for executive function and rational thought, must fully reactivate, restoring the capacity for logical analysis and self-reassurance. During the episode, the prefrontal cortex is less active, similar to its state during REM sleep. This is why logic and reason feel distant during the experience, why the person cannot easily talk themselves out of the fear. As full wakefulness returns, so does the capacity for rational thought, and the person can begin to contextualize what happened, to recognize it as sleep paralysis rather than a genuine threat. The body's reboot after paralysis involves recalibrating the systems that were temporarily out of sync. The proprioceptive system, which tracks the position and movement of the body in space, must adjust to the return of voluntary movement. The vestibular system, responsible for balance, may also need a moment to stabilize. The person might feel a brief sense of vertigo or disorientation as these systems come back online. Stretching or moving the limbs deliberately can help speed this recalibration, providing the brain with clear sensory feedback that normal function has returned. The mind's interpretation of safety after an episode is not immediate. Even after movement is restored, the memory of the hallucinations lingers. The room may still feel wrong, charged with the residue of fear. The person may turn on lights, look around carefully, check closets or corners, seeking reassurance that nothing is actually there. This behavior is not irrational. It is the brain's way of confirming that the threat has passed, that the environment is safe. Only after this reassurance can the nervous system begin to relax. Why some people experience sleep paralysis repeatedly while others encounter it only once or never is not entirely understood. Genetic factors may play a role, as some research suggests a familial tendency towards sleep paralysis. Differences in brain chemistry, in the regulation of REM sleep, or in the sensitivity of threat detection systems could all contribute. Chronic stress, trauma, and certain mental health conditions are associated with higher rates of sleep paralysis. Sleep disorders, such as narcolepsy, which involves dysregulation of REM sleep, are also strongly associated with frequent episodes. But many people who experience recurrent sleep paralysis have no underlying sleep disorder or mental health diagnosis. For them, the episodes remain an occasional, unexplained intrusion into their sleep. The timing of sleep paralysis, the fact that it usually occurs at night or during sleep periods, is simply a function of when REM sleep happens. REM periods occur cyclically throughout sleep, with longer and more intense REM phases happening in the later part of the night. Sleep paralysis is most likely to occur during transitions into or out of these REM periods. If a person wakes suddenly from REM sleep, or if they enter REM sleep while still partially conscious, paralysis can result. This is why sleep paralysis sometimes occurs when falling asleep rather than upon waking, a variant called hypnagogic sleep paralysis. The more common form, hypnopompic sleep paralysis, occurs upon waking from sleep. Darkness amplifies the perceptual distortions of sleep paralysis. In a dark room, visual input is minimal. The brain, receiving little actual information from the eyes, relies more heavily on internally generated imagery. Shadows and dim shapes become ambiguous, easy to misinterpret. The mind, primed for threat, sees danger in these ambiguous forms. A coat hanging on a door becomes a figure. A pile of clothes takes on the vague outline of something crouching. The lack of light removes the corrective feedback that clear vision would provide. In daylight or bright artificial light, the hallucinations are less convincing. The brain can more easily compare its internal constructs to the actual environment and recognize the mismatch. In darkness, that comparison is much harder, and the hallucinations dominate perception. Silence plays a similar role. In a quiet room, the absence of sound creates space for the brain to generate auditory hallucinations. The mind, expecting to hear something, manufactures sounds to fill the void. A quiet house late at night is the ideal environment for the auditory cortex to project whispers, footsteps, or breathing sounds into the silence. Any small, real noise, a creak of the house settling, the hum of a distant appliance, can be misinterpreted or incorporated into the hallucinatory experience, seeming closer, louder, or more deliberate than it actually is. The lasting impression left by sleep paralysis is not merely the memory of fear. It is also a sense of having encountered something beyond normal experience, something that felt more real than a dream and more intrusive than ordinary waking life. This sense can linger, coloring the person's relationship with sleep and darkness. Even those who intellectually understand the neurological basis of the experience may find themselves feeling uneasy at night, checking the room before turning off the light, or preferring to sleep with the light on. The body remembers the fear even when the mind has reasoned it away. This is the nature of amygdala-mediated memory. It is not easily overwritten by logic. The brain learns fear from sleep paralysis in the same way it learns fear from any intensely threatening experience. The amygdala encodes the association between the context, being in bed, in the dark, unable to move, and the overwhelming sense of danger. Future situations that resemble this context can trigger a fear response, even in the absence of paralysis. This can lead to anticipatory anxiety about sleep, which in turn disrupts sleep quality and potentially increases the likelihood of further episodes. The cycle is self-reinforcing. Breaking this cycle requires both understanding and habituation. Understanding alone is not always sufficient to eliminate fear, but it provides a cognitive framework that can reduce the intensity of the emotional response. Knowing that the hallucinations are not real, that the paralysis is temporary, and that the experience is a well-documented neurological phenomenon can make the experience less mystifying and therefore slightly less terrifying. Habituation occurs when repeated exposure to a feared stimulus, in the absence of actual harm, gradually reduces the fear response. For those who experience sleep paralysis frequently, habituation can occur naturally over time, as the brain learns through repeated experience that the episodes, while unpleasant, pose no real danger. The experience of sleep paralysis is, in a sense, the brain's attempt to protect itself from information it cannot fully integrate. The waking mind and the dreaming mind are not meant to coexist. They represent different modes of processing, different states of consciousness that the brain usually keeps separate. When they overlap, the result is confusion. The brain does its best to make sense of the situation, but the tools it has available. Fear responses designed for physical threats, perceptual systems designed to construct coherent sensory experiences, social cognition designed to detect other beings, are not well suited to the task. The brain creates a narrative of danger because danger is the interpretation that best fits the emotional and physiological data it is receiving. The narrative is wrong, but it is the best the brain can do with the conflicting information it has. The slow return to calm after an episode is a process of reintegration. The mind must reconcile the memory of the hallucinations with the reality of the empty, safe room. The body must transition from a state of high alert back to relaxation. The breath must slow, the heart rate must drop, the muscles must release their tension. This process cannot be rushed. It happens on its own timeline, governed by the autonomic nervous system as it shifts from sympathetic dominance back to parasympathetic balance. The person can facilitate this process by focusing on slow, deep breathing, by deliberately relaxing tense muscles, by turning on a light and grounding themselves in the present reality. But the nervous system will take the time it needs to fully reset. The fading of the experience, the way the memory of it becomes less immediate and less emotionally charged over time, follows the normal course of memory consolidation and decay. Highly emotional memories resist fading longer than neutral ones, but even emotional memories eventually lose some of their visceral power. The brain, encountering no further harm from the remembered event, gradually downgrades its emotional significance. The memory remains, but the fear attached to it diminishes. This process can take days, weeks, or longer, depending on the individual and the intensity of the original experience. Sleep paralysis does not damage the brain. It does not cause physical harm. The fear, while intense, is transient. The hallucinations, while vivid, are not symptoms of psychosis or mental illness. The experience is unsettling and can be deeply distressing, but it is not dangerous. Understanding this fact is perhaps the most important step in reducing the power the experience holds. The mind that knows it is not in danger can begin to release the fear, to observe the hallucinations with a degree of detachment, to recognize them as the brain's own misfiring rather than as external threats. The body, frozen in its bed, is not trapped by anything external. It is held by its own neurology, by the chemical signals that have not yet cleared, by the timing error in the transition between sleep stages. The mind, awake and aware, is not facing a malevolent presence. It is facing the output of its own threat detection systems, hyperactive and unchecked by the moderating influence of the prefrontal cortex. The pressure on the chest is not a weight imposed from outside. It is the altered sensation of breathing combined with the expectation of suffocation, interpreted as external force. The shadow in the corner is not a being. It is the brain's projection of danger onto an ambiguous visual stimulus, shaped by cultural archetypes and personal fears. The whispers are not voices. They are the auditory cortex filling silence with anticipated sound, the brain's attempt to explain the unease it feels. The sensation of being touched is not contact. It is the somatosensory cortex generating phantom sensations in response to the same mismatch between expectation and reality that produces all the other hallucinations. The brain is not malfunctioning in the sense of being broken. It is operating according to its design, but in a context its design did not anticipate. The systems that produce sleep paralysis evolved to serve adaptive functions. REM atonia prevents injury during dreaming. The amygdala's threat detection keeps the organism alert to danger. The perceptual systems construct coherent experiences from fragmented input. These are all useful capacities. Sleep paralysis is what happens when these capacities interact in an unusual way, when the boundaries between sleep and waking blur and the brain's tools are applied to a situation they are not meant to handle. The universality of the experience across human cultures and throughout history speaks to its roots in shared neurobiology. Every human brain contains the same basic structures, wired according to the same genetic blueprint. The variations between individuals are relatively minor compared to the overwhelming similarities. When the conditions are right, REM sleep, interrupted transitions, the right confluence of stress and fatigue, any human brain can produce sleep paralysis. The fact that the experience has been documented for thousands of years, described in ancient texts and folklore from around the world, confirms that it is not a modern phenomenon linked to contemporary stressors or technologies. It is a fundamental aspect of how human brains operate, a quirk of the system that has always been present. The explanations have changed as human knowledge has expanded. Where once demons and spirits were invoked, now neurotransmitters and brain regions are named. But the experience itself has not changed. The person lying paralyzed in the dark, feeling the weight on their chest, and sensing the presence of something malevolent, is having the same experience their ancestors had centuries ago. The interpretation differs, but the raw phenomenology is the same. This continuity across time is a testament to the stability of the underlying biology. The absence of danger in sleep paralysis, the fact that it is ultimately harmless, does not make the experience less real or less terrifying for those who endure it. The fear is genuine. The hallucinations are vividly perceived. The sense of helplessness is profound. Dismissing the experience as just a brain error does not capture the subjective reality of it. From the inside, in the moment, sleep paralysis is an encounter with something overwhelming and inexplicable. Only afterward, with distance and understanding, can it be reframed as a neurological quirk. In the moment, it is simply terror. The mind cannot think its way out of sleep paralysis. The paralysis will lift when the brain's chemistry allows it, not before. The hallucinations will fade when the neural activity that generates them subsides. The fear will release when the amygdala disengages and the prefrontal cortex reasserts control. These processes happen on their own schedule. The person experiencing the paralysis is not in control of the timing. They can only endure, wait, and try to maintain some thread of awareness that the experience is temporary. For some, this waiting is brief. For others, it stretches into what feels like an eternity. The subjective experience of time during paralysis is one of its most cruel aspects. A minute becomes a vast expanse, each second weighted with fear and the desperate wish for movement. The inability to gauge how long the paralysis has lasted or how much longer it will continue adds to the sense of helplessness. The mind races, counting seconds, trying to force the body to respond, and finding no success. The moment when movement finally returns can be abrupt or gradual. A finger twitches, a toe flexes, the jaw can open, allowing a sound to emerge. Sometimes the whole body releases at once, and the person gasps, sits up, or rolls to the side. The flood of relief is immediate and intense. The ability to move, taken for granted in every other moment of waking life, feels precious and hard-won. The person may move deliberately, stretching limbs, turning the head, checking that full control has returned. The room, in the aftermath, is just a room. The shadows are just shadows. The silence is just silence. The mind, now fully awake and grounded in waking logic, can see the environment for what it is. The hallucinations do not survive the return of movement and clear perception. They vanish as though they were never there, leaving only the memory and the residual fear. This dissolution of the experience, the way it evaporates once the paralysis ends, is both a relief and a source of doubt. The person may question what they saw, what they felt, whether it was as real as it seemed. The memory insists it was real. The waking mind insists it was not. The gap between these two assessments can be disorienting. How can something feel so utterly real and yet not be real? How can the brain deceive itself so completely? The answer lies in the nature of perception itself. Perception is not a passive recording of external reality. It is an active construction, a simulation built by the brain from sensory data, memory, expectation, and context. Most of the time, this simulation aligns closely with external reality because the sensory data is clear and consistent. But when the data is ambiguous or when the brain state is altered, the simulation can diverge from reality. The simulation still feels real because realness is a quality the brain assigns to its constructions, not a property inherent in the external world. During sleep paralysis, the brain constructs a simulation that includes threats, presences, and sensations that have no external source, but it assigns them the same quality of realness it assigns to genuine perceptions. The person cannot tell the difference because there is no internal marker that distinguishes hallucination from perception. Both feel the same. This is why understanding the mechanism does not make the experience less convincing in the moment. Knowing that the shadowy figure is a hallucination does not prevent the brain from generating the figure or from assigning it the quality of presence and threat. The knowledge exists in the prefrontal cortex, in the realm of explicit reasoning. The hallucination arises from deeper, more automatic systems that do not take orders from the prefrontal cortex. The two parts of the brain are not in good communication during sleep paralysis. The reasoning mind can know the truth, but the perceptual and emotional systems proceed as though the threat is real. The struggle to remain calm during sleep paralysis, to hold on to the knowledge that the experience is not dangerous, is a struggle between different systems within the brain. The prefrontal cortex, if it can remain engaged, whispers reassurance. This is temporary. This is not real. This will pass. The amygdala shouts alarm. Danger, threat, trapped, cannot escape. The outcome depends on which system dominates. In most cases, especially in early episodes or severe cases, the amygdala wins. The fear overwhelms any attempt at rational reassurance. Only with repeated experience and deliberate practice can the balance shift, allowing the prefrontal cortex to maintain a foothold and modulate the fear response. The experience teaches the brain something about its own nature, about the gap between perception and reality, about the power of fear to shape experience. This lesson is not always welcome. It can be unsettling to realize how easily the mind can be deceived, how little control one has over one's own perceptions and emotions. But it is also a lesson in resilience. The person survives the experience. The fear passes. Movement returns. The world is still the same. The brain, for all its misfiring, returns to normal function. The capacity to endure something so intensely distressing and emerge unharmed is, in its own way, a demonstration of the brain's robustness. Sleep paralysis occupies a strange territory in human experience. It is not a dream, not an illness, not a supernatural event. It is an artifact of the brain's complexity, a rare glimpse into the machinery that usually operates invisibly beneath consciousness. The systems that protect the body during sleep, the systems that detect threat, the systems that construct perception, all of these are revealed in their raw form during sleep paralysis, unmediated by the smooth integration that characterizes normal waking life. The experience is a window into the neural processes that shape every moment of consciousness, processes that are usually so seamless they go unnoticed. Understanding sleep paralysis does not eliminate it. Episodes can still occur in those who know exactly what is happening, but understanding changes the meaning of the experience. It transforms sleep paralysis from an inexplicable and possibly dangerous event into a known neurological phenomenon, unpleasant but harmless. This shift in meaning can reduce the anticipatory anxiety that surrounds sleep, making future episodes less likely and less severe. It can also reduce the distress during an episode, as the person can remind themselves, even in the grip of fear, that this is temporary and not real. The brain's eventual release of the body from paralysis is automatic, governed by the same processes that regulate all sleep transitions. The atonia ends because the neurochemical signals that maintain it are metabolized and cleared. The motor cortex resumes its normal function. The sleep cycle moves forward, either into waking or into another stage of sleep. The person does not will this release into being. They cannot force it through effort. It happens because the brain's timers and regulatory systems move to the next phase. The person is a passenger in this process, waiting for their own neurobiology to release them. The memory of sleep paralysis can serve as a marker, a point in time that stands out because of its intensity and strangeness. People remember where they were, what bed they were sleeping in, the layout of the room, the quality of the darkness. These details become linked to the emotional weight of the experience. The memory is not just of the paralysis itself, but of the entire context, the moment of waking into immobility, the hallucinations, the fear, the struggle, and finally the return of movement. This full narrative is encoded as a cohesive memory, more story-like than most sleep-related experiences, which tend to be fragmented and quickly forgotten. The brain's tendency to create stories, to impose narrative structure on experience, is particularly evident in how sleep paralysis is remembered and described. The person does not recall a series of disconnected sensations. They recall a sequence: waking, realizing they cannot move, sensing the presence, seeing the figure, feeling the pressure, fighting to move, finally breaking free. This narrative structure makes the memory more coherent and easier to communicate, but it also reinforces the sense that something happened, that there was an event with a beginning, middle, and end. In reality, the experience is more diffuse, a collection of simultaneous neural processes that the brain retrospectively organizes into a linear story. The communication of sleep paralysis experiences, the sharing of stories between people who have had similar episodes, serves a social function. It provides reassurance that the experience is not unique, not a sign of individual pathology or strangeness. Hearing that others have encountered the same shadowy figures, the same chest pressure, the same sense of malevolent presence, normalizes the experience. It places it within a shared human context rather than isolating the individual. This communal aspect of sleep paralysis, the recognition that it is a widespread phenomenon, can be deeply comforting to those who have felt alone in their fear. The scientific study of sleep paralysis has provided much of the understanding that now exists. Researchers have mapped the neural correlates of the experience, identified the brain regions involved, and traced the neurochemical processes that produce autonia and fear. This work continues, as there are still aspects of sleep paralysis that are not fully understood. Why do some people experience it frequently, while others never do? What determines the specific content of the hallucinations? Are there interventions that can prevent episodes or reduce their frequency? These questions remain open, subjects of ongoing investigation. The value of this research extends beyond sleep paralysis itself. Understanding the mechanisms of sleep paralysis sheds light on broader questions about consciousness, perception, and the sleep-wake boundary. It reveals how fragile the distinction between sleeping and waking can be, how easily the two states can bleed into each other. It demonstrates the extent to which perception is constructed rather than passively received. It shows how emotion can shape sensory experience, how fear can literally change what a person sees and hears. These insights have implications for understanding other conditions where perception and reality diverge, such as psychosis, sensory deprivation, or altered states induced by drugs or meditation. The experience of sleep paralysis, while distressing, is also a reminder of the brain's remarkable complexity. The same neural systems that produce the terror of sleep paralysis also enable dreaming, imagination, memory, emotion, and the rich inner life that characterizes human consciousness. The brain is not a perfect machine. It has quirks, glitches, moments when its systems misfire or interact in unintended ways. Sleep paralysis is one of those moments. It is the price paid for a brain capable of such intricate and flexible functioning. The quiet return to normal after an episode, the gradual settling of the nervous system, the fading of the adrenaline, the slowing of the heart, the deepening of the breath, all of this is the brain restoring equilibrium. The systems that were thrown into disarray by the overlap of waking and sleeping gradually find their proper alignment. The person lying in the dark or turning on a light, breathing deeply, checking the room one more time, is participating in this restoration. They are helping their brain return to baseline, providing the sensory feedback and the cognitive reassurance that the emergency has passed. Sleep, when it returns, may come easily or with difficulty. Some people fall back asleep quickly after an episode, their exhaustion overriding any lingering anxiety. Others lie awake for a long time, reluctant to close their eyes, afraid the paralysis will return. The body is tired, but the mind is wired, still processing the experience. The decision to try to sleep again is an act of trust, a willingness to surrender control once more to the unconscious processes that govern sleep. For those who have just experienced the betrayal of waking into paralysis, that trust may be hard to summon. The night moves forward. The darkness outside remains unchanged. The room is still. The world continues in its indifferent rotation. The experience of sleep paralysis, so overwhelming to the individual, is invisible to the rest of reality. It leaves no mark on the external world, only on the internal landscape of the person who endured it. The memory will fade, the fear will diminish, and eventually the episode will become another story, another data point in the long catalog of human experiences that are strange, unsettling, and ultimately survivable. The brain, resilient and adaptable, moves forward. It continues its nightly cycle of sleep and waking, descending into REM and rising again, regulating autonia and releasing it, generating dreams and dissolving them upon waking. Most nights, the transitions are smooth. Most nights, the boundaries hold. Most nights, the waking mind and the dreaming mind remain separate, each in its proper place, each doing its job without interference from the other. Sleep paralysis is the exception, the rare moment when the boundaries fail, when the machinery is briefly visible, when the person becomes aware of processes that are meant to remain hidden. In that awareness, uncomfortable as it is, there's a kind of knowledge. The person who has experienced sleep paralysis knows something about the nature of consciousness that others may never encounter directly. They know that the mind can be awake while the body is asleep. They know that perception can be utterly convincing and utterly false. They know that fear can be generated from within, with no external cause, and that it can feel as real as any threat the world has ever posed. They know that the brain is both the self and something other than the self, an organ with its own logic and its own vulnerabilities. This knowledge, hard-won and unwelcome, is nonetheless a form of insight. The silence after an episode, the stillness of the room, the slow return of calm, these are not empty moments. They are moments of reintegration, of the mind and body finding their way back to synchrony. The person lies quietly, breathing, feeling the weight of their limbs, the softness of the mattress, the coolness or warmth of the air. These sensations, mundane and ordinary, are grounding. They anchor the person in the present, in the physical reality of their body and their surroundings. The hallucinations, which felt so solid and present, have vanished completely. The presence is gone. The shadow has dissolved. Only the person remains, alone in their room, as they were before the episode began. The knowledge that sleep paralysis is temporary, that it always ends, that no harm comes from it. This knowledge is the antidote to the fear it generates. It is the light that dispels the shadow. It does not prevent future episodes, but it changes how they are experienced. The person who understands sleep paralysis can face it with less terror, can remind themselves, even in the grip of immobility, that this is a known phenomenon, that it will pass, that they are safe. This understanding is not a shield that makes the experience comfortable, but it is a tool that makes it bearable. The night stretches on. The person may sleep again, or they may lie awake until dawn. The darkness outside will eventually give way to light. The world will wake. The ordinary concerns of the day will reassert themselves. The episode of sleep paralysis will recede into the past, becoming a memory, a story to tell or to keep private, a moment of intensity in the long arc of a life made up of many such moments. The brain, for all its complexity and occasional misfiring, carries on. It sleeps and wakes, dreams and forgets, constructs perception and navigates reality. It is resilient. It is adaptable. It is in its own way quietly extraordinary. The experience fades. The fear fades. The memory remains, but its sharp edges soften with time. The person moves forward, carrying the knowledge of what happened, the understanding of what it meant, and the quiet assurance that they survived it. The brain, that intricate and imperfect organ, continues its work, weaving consciousness from neurons and chemistry, creating the self from processes that operate mostly in shadow, occasionally revealing themselves in strange and unsettling ways, but always, in the end, returning to the steady rhythm of ordinary life. The stillness returns. The breath slows. The body rests. The mind, no longer held in the strange territory between waking and sleeping, settles into one state or the other. The episode is over. The night moves on. The understanding remains, quiet and persistent, a small light in the darkness, enough to guide the way forward.